Hello, everyone, and welcome to today's lecture. So if you look at the lecture schedule, you will see that next week will be our midterm. And we'll send out an announcement about it for those who don't attend the lecture after this lecture. In general, it will be online, of course, because not all of you are in Hong Kong. And we're going to use Canvas quizzes for that. Okay, so you can answer, so you will be able to enter your answers using the answer box in Canvas quizzes. It will be an open book exam. Okay, and the main topics will be ER diagram, relational model, and how we can do the mapping, and also SQL. Yeah, so it will be next week, right? So according to the schedule that it has been online for some time, it's next week. No, you don't need to have any camera on or anything because it's not the final exam, so it doesn't need to follow the 2-device policy. And yeah. Okay, so I will say more about it in the announcement that I'm going to send. And if you have any questions after that, you can still get in touch. Okay, so last time we discussed SQL, and we discussed quite a bit about how to do simple queries. And now we're going to look at how we can use SQL as a data manipulation language. So in SQL, the database can be modified using 3 commands: insert, delete, and update. Okay, and so let's start with insert. Now, what does insert do? Well, you might have already seen it for the tutorial, because we use these insert commands to create the tuples for the database that you used in lab 1. So insert is used to add a single tuple to a relation or table. And we must, of course, specify the relation name and the list of values for the tuple. Okay, so this command here is an example. So we're inserting this tuple here into the employee table. Here is another example. And this is a bit more involved because you can see that we're actually using the values for the attributes by writing a select statement. Okay, so this is basically the same as up here, the syntax, right? So insert into, we're inserting something into the works on info table. And now we have these attribute names here. And the values for these attribute names are the result of this query down here. All right. So this is often used to insert derived attributes. If you remember from our discussion of the ER model, so the derived attribute is one that you can compute from other attributes. The second command that we need to look at is the delete command. So that removes tuples from a relation. And the syntax is very simple. So you need to write delete from and then the table name. So this operation will delete all the tuples from the table, but of course the table itself, meaning the specification of the table, still exists. It's just empty. Now, in many cases, you don't want to delete all the tuples from your table because that's a very drastic step. So you can add a where clause to select only the tuples that you want to delete. Down here, you can see several examples for this. So in this first command here, we're deleting all tuples from the employee table where the last name is equals to Brown. And here we're deleting all employee tuples where the social security number is equals to this number. And here we're checking whether the department number is equal to this number. And this last command here just deletes everything as mentioned. And the third command that I want to mention is the update command. So that is used to modify attribute values of one or more selected tuples. So you can add an additional set clause to your update command. That will specify the attributes to be modified and also the new values. So again, let me give you an example. So here we're updating the project table, and we're using this set clause here. Okay, so we're going to set the project location to Bel-Air and the department number to 5 for all tuples that satisfy this condition here in the where clause, namely where the project number is equals to 10. Another feature of SQL that I want to explain now at this point are views, or also known as virtual tables. So far, we talked about base tables. Those are the ones that you create using create table. And these are actually physically stored as a file by the database management system, these base tables. Now, on the other hand, views or virtual tables don't really exist as files. So they might exist in your memory, but not necessarily in the secondary storage. Usually you will use views if you only need them temporarily. So sometimes you can use a view to simplify writing SQL query. Now let me give you the syntax for how to create a view. So the command is create view. And here are two examples. So here in the first one, we're creating the view works on 1. Okay, and how are we creating it? Well, we're creating it as the result of this select statement here. Okay, so that's what this as select means from. And it has 4 attributes to view. And we're selecting from these 3 tables that we're joining using these 2 join conditions down here. All right, and after we created this view up here, we can actually use works on 1 just in the same way as we use the other tables when we write queries. Okay, and down here we have another possibility for creating a view. This is actually a bit more advanced because it's using these aggregate functions, count and sum. So don't worry if you don't yet know what these mean. We'll talk about these later on today. All right, so what this view does is that we are selecting from the department and the employee table, and we're joining them along the department number. Okay, so we have now 1 joined table. And also we have a group by, so this is a really advanced query. Again, I haven't explained to you yet what group by does. Just the intuition is that it will basically group the result of this query here into groups, where the tuples in each group have the same value for this d-name. Okay, but we'll talk much more about group by in a few minutes. And then maybe later on, you can come back and look at this view here, and then that will make more sense. Any other questions so far? So sometimes these base relations that we're using here in the department and the employee, they're called the defining relations of a view. And you can see that here in this first, in V1, in this command, we use the same tables from the base tables, right? So we just use exactly the same attributes. The same attributes. So we're using the same attribute names. And here in version 2, when we create this view, So we're using different attribute names, right? So the reason for that is that I'm actually doing some arithmetic on these tuples, right? So I'm summing up over the salaries for each group, and therefore I'm calling the resulting attribute total salary. I'm sure you can also use the asterisk if you like, if you want to just select all attributes from the defining relations. At least it does seem to work in most SQL implementations. You would need to be careful because there's so many implementations of SQL, and not all of them are compatible with each other, unfortunately. Now, once we have our views, as I mentioned, we can just use them in exactly the same way as we use the base tables, right? So this works on one view. I can now just select, for example, the first name attributes and have some conditions here in my where clause. The nice thing, and what really makes them a killer feature of databases, is that they're kept up to date automatically by the database management system. So basically, that means that if someone inserts new data into your base tables, let's say, we go back to the definition. So let's say I'm inserting new tuples into department, then this will automatically update the view that I created, which is called department info. So I don't need to issue any other commands for that to happen. At some point, you might be done with your view, so you can use the drop view command. And that works analogously to the drop table command, right? So you just write the name of the view that you would like to get rid of. So there's a question whether the create view table is stored. So that again depends on the SQL implementation. So in most cases, I would say yes, but the best approach is to try it out. So there's some limitations when we deal with views. Okay, so you need to be careful. So I don't really want to go into this example here. Basically, we're just going to follow the following rule. So you can only do a modification through a view if the view is defined in terms of a single base relation. Okay, so what this means is that unfortunately for neither of these two views that we're creating here, we can do a modification because they're not defined by a single relation, right? So this one is defined by 2 and this one even by 3. All right, so just keep that in mind when we try to deal with views and try to update data in views directly. So what I'm talking about here is that we can add or modify data in the views and not just in the base relations. All right, so this completes the slides that I have prepared for last week. And now let me start the second slideshow. So I'll also, by the way, add some practice questions in Canvas quiz just to give you a chance to actually get familiar with how to use Canvas quizzes if you haven't yet, because I don't want that to be causing any problems, right? So the midterm exam should just test your knowledge or not, whether you're very familiar with Canvas. And again, I will add this to the announcement that I'm going to send out later today. Okay, so there's a question in the chat. So views is directly, yeah, views are directly connected to the original data. Yes, you can think of it that way. And with this Yeah, so it's no, it's so the midterm is not multiple choice. So you need to write your answers into the answer box. Okay. Good. I think now you can see my second set of slides. So I will send out all that in the announcements. Okay, so don't worry about it now. We'll see it later today. All right, so now we're talking about more advanced ways to write queries in SQL. And again, we're going to use this company database as a running example. And just like last time, we're going to assume that the database is filled with this state here. All right, so this is just for you to keep in mind that we always have this employee table, which has the primary key social security number, department is primary key D number, and employee has a foreign key to departments, and department locations also has a foreign key to D number, and so on. Okay, so I don't want to explain this again. Just keep this in mind for now. And last time we talked about the basic structure of select statements. So we have this select from where structure here, right? And after select, we write the attributes that we want to list. Then after from, we write the tables from which we are querying. And after where, we write any conditions that we want to impose on the tuples. So sometimes you want to use existing values in the database in a comparison condition. For example, maybe we want to find all the employees that have a dependent with the same first name, meaning with this same first name as the employee. So how are we going to do that? That's kind of tricky because so far, when we wrote these conditions for the where clause, we always used constants or literal values. Okay, so we need to use something else for that. And the answer for how to do this is using nested queries. What's a nested query? Well, it's basically a complete select from where block that is nested within another SQL query. And we call the inner query the nested query. And the outer query is, of course, the outer query. So the nested queries can appear in various places. It can appear as part of the conditions that you write for your where clause, but it can also show up in the from clause, as we'll see an example for later, and also in the select clause, and then the other clause as needed. So the other clauses that we haven't discussed yet, such as having. Now let's see how we can write these nested queries by using the comparison operator called in. So what does in do? Well, it compares a single value, let's call it v, to a set or multi-set of values. Okay. So the syntax would look like this. So v in capital V. So this will evaluate to true if v is one of the elements in V. So let's look at an example here. So we want to retrieve all project numbers for projects that involve an employee whose last name is Smith, either as a worker, meaning he works on that project, or as a manager of the department that controls the project. This is already a bit more complex than the queries that we discussed so far. So let's see how we can do that. Okay, so this is the answer. And you can see that we have actually not just one nested query here, but two. All right, so let's try to dissect this example and see what is going on here. So let's start at the nested queries, at the inner queries here, okay? Because we kind of need to do that to make sense of what is going on with this outer query. So what does this first inner query here do? Can someone tell me? Well, we're selecting the project number from the project and the department employee table. So we are looking at three tables here. So that means we need to, of course, join these three tables, and we're joining them along the department number and also along the manager social security number. Okay, that gives us the join between the three. All right, and then we also have this condition here that the last name should be Smith. Okay, so we're selecting all project numbers that are managed by someone with the last name Smith. So that's just what this nested query here does. All right. Now this was the first nested query. Now we have another nested query down here. Let's see what this does. Okay, so this shouldn't be too difficult, right? So we're selecting again the project number, but now we are selecting it from the table that we get by joining works on and employee. So we're joining these two along the employee social security number. And again, we're selecting the last name to be Smith. Okay. So what is the second query here does is that gives us all the project numbers of projects that have an employee working on it with the last name Smith. Okay, so now that we have these two nested queries here, we're almost done. Because our goal is to retrieve all project numbers that show up in either of them. Okay, so we're going to, so how do we test that? Well, so now let's look at the outer query. So here we have a select distinct statement. So this eliminates the duplicates, and we're selecting the project number from the project table, but restricting the project number to be in the result set of this first query, or to be in the result set of the second query. All right. Any questions about this? So the way it works is that we have these two nested queries. There's a question in the chat. Can you tell us the operation in tables? Not sure what you mean by the operation in tables. Also, it's I guess. Anyway, let me try to explain this again. So we have these two inner queries here, right? These two inner select statements. So if you just execute this one on the company database, you'll get all the project numbers that are managed by someone with the last name Smith. Okay, so yeah, it's okay. Yeah, it's a good idea to try it yourself. Actually, what I'm going to upload later on today is also the database definition of this company database. So you can try out some of these examples yourself without creating the whole database, which is quite large. I should get to it later tonight. If you're looking for it tomorrow and it's not there, please remind me. Okay, so this first query here, so just what it does, that should be clear, right? Because it's a very simple query. It only uses the things we discussed last week. So it joins these three tables: project, department, and employee. So it joins them using these two join conditions. So so maybe let me go back to the. Actually, this is not part of the slide set, so I can't really show you the database state, unfortunately, without closing the slide set. Let me see if I can find it here quickly. Doesn't look like it's. Here we are. Okay, so all right, so we're selecting from project, department, and employee. Okay, and we're joining these three tables in the inner query. And we're joining the department table with the project table along this attribute dnum here and d number here. Okay, because we need that to get to the manager social security number. And then we're joining the resulting table with the employee table, where the joining attribute will be SSN and manager social security number. All right. So this here is our inner query, our nested query. And similarly, this here is also our nested query. Okay, so both of these are nested queries. That makes sense? And of course, this is the outer query. Yes. All right. Okay, good. Any more questions about this? Yeah, so yeah, I mean, it depends on whether you want to call the whole thing a nested query, right? But usually I would just refer to this as the nested query. Okay, so that's the inner query. All right. And yeah, as once we have these two result sets, right? So then we're just checking whether project number is inside this set or if it's inside this set. And if either of the two is true, or even both of them are true, then we include it into the projects that we're selecting here. So sometimes we don't need to use in. So if a nested query, so meaning this, again, this inner query here, if that returned only a single tuple, then I can use this equal sign instead of the in operator. But you know, if there's more than one tuple in the result set, then you have to use in. So just to be safe, you can just always use in. That will work. So you can also use in to compare tuples of values by placing them within some parentheses. So let's look at this example here. So let's say we have a set of tuples A1, B1, A2, B2, A3, B3, right? And now I could write the comparison like this, right? I could ask if A1, comma B1, so this tuple here, in set V, all right? And that will return true. Let's look at another example in the company database. So we want to select the employee social security number of all employees who work the same project and number of hours as the employee with the social security number 1, 2, 3, 4, all the way up to 9. So let's see how we can get that. And again, we're going to use a nested query. All right, so again, we're going to start by dissecting what is going on here by looking at the inner query here. So we're selecting the project number and the number of hours from the works on table, but we're restricting ourselves to the tuples where the social security number is the one that we're interested in. Okay. And then we're almost done, right? Because this gives me, so what does this give me? Well, it gives me all the project number and hours tuples that are worked on by this employee with this social security number. So I'm going to use this in my outer query to now select all the tuples from the works on relation. I'm just going to select the social security number where the P&O and hours is inside this set. Okay, that makes sense. All right. You mean what is the difference to using where? You mean just using like this condition here, up here? Okay, so what is that going to give me if I don't have this nested query here, if I just have this condition? Well, it's just going to select all tuples that are being worked on by this employee with the social security number. Okay, so it won't select, it won't select anything else except that. So maybe I can go back again to the states that I just showed you before. Where's our works on? Here we are. Okay, so if I just have the where, this where condition, it will only select this one, and that's it. All right. So you can see that this is not what we want, right? Because what we wanted was to get the social security number of all employees that are working on the same project as the employee with that social security number. But now I just got these two tuples, which are the ones that he's working on. So that is not the answer that I want, right? Okay, in fact, my result will just be, my result will be what if I have this? Well, it will just be 1, 2, 3, 4, 5, 6, 7, 8, 9. There's a question, otherwise it will return false. What will return false? So it's not just a matter of ambiguity here, right? It's a completely different query if you only have this where condition up here and you don't have this nested. query. All right. So I'm not sure what you mean by SQL would return false. Oh, so what SQL return? So if the condition doesn't hold, if a where condition doesn't hold, that just means that I'm omitting that tuple in my result set, right? So SQL doesn't evaluate Boolean formulas as a result. What it gives you is a list of tuples, and it will just filter out all tuples that don't satisfy your conditions. Okay. All right. So you can use several comparison operators to compare single value V to a set or a multiset of tuples, capital V. And the way we can do that is by adding the keywords any or some or all. So any and some are the same in most SQL implementations. So if, for instance, you can write equals and then any or equals and then some, that will return true if the value V that you have on the left-hand side is equal to some value in the set V. Okay, so basically this, so writing V equals any V, that is the same as writing V in V. All right. So you probably don't want to use equals any or equals some. That's the upshot of that point. But of course, that works not just for the equals operator, it also works for any of these operators that you have down here, for greater, greater equals, and so on. And just to remind you, this less than and then greater than, that is how we denote the not equal sign in SQL. Now, what about the all keyword? Well, you can also add an all after these comparison operators. So what does V greater than all V mean? Well, it will return true if the value V is greater than all the values in the set V. That should be intuitively clear. So let's look at an example. Let's look at this query here, and let me start the poll to see if any of you can guess what it actually does. And fingers crossed that Zoom is actually going to show me the result of the polling. And it does today. Good. And try to answer within the next 20 seconds. All right. And most of you got the correct answer. So this will select the names of all employees whose salary is greater than the salary of all the employees in department number 5. So because we're not, so there's a question in the chat why we're not using the in comparison operator. Because we're not testing for set membership here, right? So I don't want to check whether the salary, I don't want to select all employees that have a salary that is in the set of the employees that are selected here. So it's a good question. So let's maybe consider this query. So can someone tell me what that would return? So it would give me the last name and first name of all employees that have a salary that is equals to at least one salary of some of an employee working in department number 5. Okay, that's right. Yeah. And of course, if we change this all here to any, then what do we get? Is it the same as in? Okay, let me try to erase this now. Now let's say we have any. What does it mean then? Exactly. So then it means that I'm selecting all employees whose salary is strictly greater than the minimum salary of someone working in department number 5. Good. Okay, so it seems that you understood these nested queries, which is good because they are very useful and also they can get very complicated. And in fact, one of these more complicated features of nested queries is what we're going to be discussing next, namely correlated nested queries. So whenever you have a condition in the where clause of a nested query that references some attribute of a table selected in the outer query, then we call it a correlated nested query. So far we didn't have that, right? Because if you look back to this example, for instance, so the where clause here didn't concern the outer query at all, right? So these were not correlated. So in that case, we can think of a slightly different way when talking about these nested queries. So it's a bit easier to think about the nested query as being evaluated for each tuple in the outer query. Okay, so this is a bit abstract, I know. So let's look at an example. So let's say we want to retrieve the name of each employee who has a dependent with the same first name and the same sex as the employee. Okay, so how can we do that? Well, for that we need to use the correlated nested query, right? Because we're saying that the first name needs to be the same and also the sex needs to be the same. So this is how we can make that work. And note that here we're using these aliases, right? So we're selecting in the outer query, we're selecting from the employee table, which we're going to abbreviate as E. So then E dot refers to attributes of this of this specific instance of the employee relation. Okay, so so how do we think about this correlated query? Because now we can't just dissect this by looking at the nested query here, because you can see that it actually references some attributes of the table that is from which we're retrieving data in the outer query, right? We have an E dot here. So we can think of this as saying that for each tuple in our employee table, for each tuple in E, we're going to evaluate this inner query here. Okay, so we're going to select from the dependent table, which we're going to use the alias D. And we're going to have this where condition here, right? So we're going to check whether the first name of our employee tuple, of the specific employee tuple that we're looking at the moment, is the same as the name of the dependent. And also we're checking if the value of the sex attributes is the same for these two tuples. Okay, and we're selecting all tuples from the dependent table where this holds. All right, so the important thing is that we looked at the meaning of this by fixing one specific instance of one specific tuple of the employee table. Okay, and then this tells us what the what this nested query does, and then we look at the where condition here. All right, and this where condition says that we only want to select those employees that are in this result set of our nested query. So we have this requirement that the social security number needs to be in this result set. And from that, we return the first name and last name. Okay, so any questions about this before the break? So to write this maybe more programmatically, in pseudocode, I could write this as, for each tuple E, in our employee table, we're going to do the following. We're going to run this nested query here. Right, we're going to evaluate that nested query and then check the where condition. Right, so evaluate nested query and then check the where clause. And if we pass the check, then we're just going to include the result of what we're returning. Okay. All right, so let's continue here in 10 minutes.
So I want to ask you a question.
Sure.
Okay, when we change the all to any, what's gonna be?
You
yes.
mean here?
Yes.
So, well, yeah, I guess someone already wrote it correctly in the chat. So it will be, so the salary needs to be strictly greater than the minimum. The minimum in here, right? So as long as that's true, this will be included in the result set, right? So you want it to be greater than any of the salaries in here. So if it's greater than the minimum, then that's already satisfied.
Greater change from maximum to minimum.
Yeah, in this case, yes.
Got it.
All right, so let's continue. And I see there's some activity going on here in the chat. I maybe missed some questions. Okay, let me just check. Has anyone's question not yet been resolved? If so, maybe you could just post your question again. So no, so okay, so there's some confusion about when to use where and in and the equals sign. I guess it's about this example here. Okay, so maybe I'll jump back to the state before we discuss this. So remember the tuples where so basically this employee with this social security number has two tuples in the works on table. Okay, the first two tuples, and delete these markings here. So when I select this, I will get two tuples, as we just saw. So I can't use the equal sign here, because I can only use the equal sign between single values, not between a value on the left-hand side and the set on the right-hand side. Okay. And after I selected these two tuples in this nested query here in this outer query, I'm selecting the social security number of all employees that have the same project number and hours in the same values as the ones that I just selected in my nested query. Okay, so again, let me go back to the states. All right, so it needs to be in this result set here. No. So maybe for this state here, because probably the answer is the empty set, but of course not in general, right? So let's say maybe I have like another tuple in my table. Let's say I have okay, that's the social security number, and I have 1 and 32.5. Okay, so that will be in my result set. So this value here would be as part of my result set. Okay, but it won't be in the result set of the final query if I just write if I omit this nested query and just have a where condition. Because if you look at what this, if you look at what this select does, if you only have a where, it doesn't really do anything at all, right? Because if I only have this where condition appear, no nested query, then you're not really selecting anything, right? Because you're selecting the ESSN, but you already fixed the ESSN to be this number here. So you're just going to return this number. Okay. All right. Let's continue then. And this is where we stopped before the break. So we just started discussing these correlated nested queries. And in that context, we often use the exist and then no exist functions So these are Boolean functions that return either true or false, and you can use them as part of the where clause. So what they do is they check whether the result of a nested query is empty, meaning the query didn't find any tuples that match the conditions that I specified. Of course, exists returns true if it's not empty, and no exists returns true if it is empty. So typically, you're going to use this in conjunction with a correlated nested query. So I can't think of any usage of using this not in a correlated nested query. So let's look at this example here. So we want to retrieve the name of each employee who has a dependent with the same first name and the same sex as the employee. Right? So this might look familiar, right? This query, because it's actually the same one that we just looked at. Let's see how we can write this using exists. Okay, so again, we're going to look at this in the, in using the conceptual intuition that I tried to give you in a previous slide, right? So I'm fixing one employee tuple, and then I'm going to evaluate the inner query for that tuple. Okay, so I fixed one employee tuple, and now I'm selecting, and I'm selecting all attributes from the dependent relation or table, which I'm giving the alias D, where the social security number is the same as the social security number of my employee that I'm looking at, right? So I'm only looking at the dependence of that employee. And also the sex is the same. And also the first name is the same as the dependent name. All right. And then here, I just, in my where clause, I'm just having this exists function. I'm applying the exists function to this nested query here. And what do I get as the result? Well, this is going to, this specific employee that I'm looking at is going to be included in my result list if they actually exist. Exists at least one dependent in here in this nested query. That makes sense? Good. So exists returns either true or false, right? Okay. Of course, also in returns either true or false, right? So these are comparison operators, so they all return Booleans. In fact, anything that you're evaluating in the where clause should return either true or false, otherwise you won't be able to use it in your where clause. Okay. All right, so let's look at another example here. And now let's look at this query, and let me start another poll. Let's see if some of you can guess what this query does. and try to answer within the next 30 seconds, please. All right. Okay, so now interestingly, the correct answer is the third option. Most of you thought that it was the second one, but I admit that this is possibly maybe a bit confusingly stated. Now, the reason why I guess many of you got this wrong was that we have this where condition here inside our nested query, where we're checking whether the social security number value inside the dependent table is the same as the employee social security number. Okay, but note that the social security number value inside the dependent table is actually a foreign key that references the social security number in the employee table. So that just connects the dependence that we're looking at to the specific employee. Okay, so so basically, again, since this is a correlated nested query, the way we can think of it is that for each employee tuple, for each tuple that we're selecting here, let's fix one of them. This nested query here will select all dependent tuples whose ESSN matches the employee SSN. And that just means that they are dependent of this employee, right? Now, if there aren't any tuples, if the result set of the select statement here is empty, then no dependents are related to the employee. Okay, and we want to find all the employees that don't have dependents. So we want this to evaluate to true. So we write no, not exists here. Okay. Okay, so let's look at another example. So here we want to list the names of managers who have at least one dependent. It's a very simple statement, but less simple when you try to write it in SQL, I suppose. So let's see what's going on here. Okay, so again, we have an outer query and two nested queries here that are correlated to the outer query. So for each employee tuple, we're going to execute this, and this first nested query will select all the dependent tuples that are independent of that employee, right? So we have this SSN equals ESSN condition here, just like before. Whereas the second nested query here will select all department tuples that are managed by that employee, right? Meaning the manager social security number from our department table is equals to that social security number attribute of the employee that we're looking at. Okay, so you can see that we have an exists here and also an exists here. So both of these conditions need to hold because we combine them with an and, right? So we want the employee to be manager of some department, and we want that employee to have at least one dependent. All right, good. And the third example, so now we want to retrieve the name of each employee who works on all projects controlled by the department number 5. So just to remind you, in the company database, each project is controlled by some department. So let's look at how this query works. Okay, so again, we have some inner queries here, and they're correlated. Well, actually, this one's so we have two nested queries here, right? So this one here, and then again, we have another nested one inside the nested query. So once you're looking at more complex applications, you'll see these multiple nested queries showing up. So let's start here. Okay, so again, we're looking at some specific employee. And here, in this first subquery, we're actually not correlated to the outer query. So we're just selecting all projects that are controlled by the department with number 5, right? Now, this is, however, not what we're returning here, right? Because we have this except statement and then another nested query here. So what does except do? Does anyone remember? We didn't discuss it today, but last week. Well, it gives me the set difference, right? So it subtracts or removes all the tuples from this result set here, which should say result multiset, that show up in this result set. Okay. All right. So coming back to this. So for now, we've selected all projects that are controlled by department number 5. And then in the second subquery, we're going to select all projects that the particular employee, right, this SSN here refers to the employee table up here, is working on. Okay, so this is a correlated nested query because it uses an attribute from a table out here. Now, the first result, minus, so except means minus in set theoretic notations, minus the second result. So if that is empty, then what does that mean? Well, it means that the employee works on all projects that are controlled by the department with department number 5, right? Because I removed all the projects that this employee is working on from the projects that are controlled by the department number 5. So if nothing is left, then clearly he's working on all projects controlled by the department number 5, and therefore I will include this employee here in my outer query because this where clause now, this not exists, will evaluate to true because this is empty. All right, and then I move on to the next tuple from my employee table, and again I will evaluate these two subqueries here. And if they're both, so if the set difference between the two is again empty, then this will again evaluate to true, and I will include it in my result set, and so on. Now, one thing, since we're using Oracle in the labs, so in Oracle you can't use except, even though in most SQL implementations you can. So you must use minus instead. All right, but of course, if in the exam you use minus or except, either of them is correct. So we won't assume any specific SQL implementations as long as what you're doing is correct in some SQL implementation, that will be fine. Okay, so now let's move on and talk about aggregate functions. So aggregate functions are used to summarize information from multiple tuples into a single tuple. So for example, I could be computing the sum of all the salaries, and that will just give me a single value. So there are several built-in aggregate functions. The first one is count. So that just returns the number of values or tuples that are in a given set or multiset. And there are also sum, max, and min, and AVG, which stands for average. So these are applied to a set or multiset of numeric values. So you can't apply them to strings, for instance, or things like that. Well, in some cases you can. So for instance, you can apply, I think, max and min because there's an ordering defined in strings. But for this lecture, let's just assume that you always apply them to numeric values. So what do these functions yield? Well, as the name says, sum gives you the sum of the values in the set, max the maximum value, min the minimum value, and AVG the average or the mean value of those values in the result sets. So we will see later on that these functions can be used either in the select clause or in a having clause. So we haven't discussed what the having clause is yet, but we'll do so very soon. So let's say we want to find the sum of the salaries of all employees and also the maximum salary, the minimum salary, and the average salary. And now you might be relieved to see that this is much simpler than these nested queries. So here's an example where these aggregate functions show up in the select clause, right? So instead of just selecting an attribute, now I'm applying these functions to the attribute that I'm interested in. Okay, and then of course I'm selecting from the employee table. So what is this going to give us, this result of the select statement? Well, it will just give us a single tuple, right? And the tuple will have these column headers or attributes, which is the sum, the max, the min, and the average. Now things become more interesting when you combine these aggregate functions with statements in the where clause. Because if you have a where clause condition, then that ensures that only the tuples that satisfy that condition will be taken into account when you compute the aggregate value that you're looking at. So let's look at this example here. So we want to compute the sum of the salaries of all employees of the research department, as well as the maximum salary, the minimum salary, and the average salary since we added. So how can we do this? Well, this is almost the same select statement that we just saw on the previous slide, right? I'm selecting this, but I can't just select from my employee table because, as we said here, we're looking at the research department. So we want to restrict that. Okay, so I need to select from two tables, from employee and department, under the condition that, what does this condition here do? Well, it just joins these two tables, right? So I want to associate the tuples from employee and department that have the same department number. And we're going to filter out all the tuples where the dname attribute is not equals to research, because we're only interested in the research department. Another example is here. Let's say I want to retrieve the number of employees in the research department. So in that case, I'm going to use the count function. Okay, so you can see here that we use count and then this asterisk inside these brackets here. All right, and what this asterisk here means is that it refers to the rows or tuples. So this count will just return the number of rows in the result of the query, which is exactly what we want. And you can see that the condition that we're using here in our where clause, DNO is equals to dnumber and dname is equals to research, is exactly the same one as the one used up here, because again, we're only interested in the research department. So let's talk a bit more about the count function. So count doesn't eliminate duplicate values, right? Because there might be some tuples that have duplicate values that in the result set that you're looking at. So if you want to eliminate that, you need to add the distinct keyword. So here's an example where we count the number of distinct salaries that show up in our database. So we're going to select from the employee table, and we have, so what we're returning is the count of the distinct salaries. All right, So what about null values? So I already mentioned to you that null values are kind of a special case, and we need to be careful when looking at evaluating Boolean functions when null values show up. So when you have these aggregate functions, in general, we're going to discard null values. So meaning if some of the salary values are set to null, then we're just not going to include them when we compute, for instance, the sum. All right, so we're just going to remove them before we perform the calculation. Now, an exception for this is the count function. So if you use count, then we're still counting the null values, even if if the column is null. And the reason is because we're counting tuples, and we don't care what values those tuples have when we use count and asterisk. Now, it can happen that all values are null for a specific attribute. What if I don't have any salary information listed in my employee table? In that case, what is the sum of the salaries going to give me? Well, it's just going to return null, because there's no other reasonable values that it can return. Again, the exception is count, which will return 0 in that case. All right, so let's look at some more examples. So here, in this query, let's see, we can see that we have actually a nested query, right? And let me run another poll to see if you're still following along. All right. Okay, let's finish in the next 20 seconds. All right, close the poll. And let's see the results. Okay, so most of you gotten that right. So that's good. So you can see that this retrieves the names of all employees who have 2 or more dependents, right? And if you look at this correlated nested query here, so that counts the number of dependents, right? Because we're using this count asterisk here, which counts the number of tuples in the result set that each employee has. Okay. And why is this a correlated query? Well, because this SSN here is an attribute from the employee table. So we're only selecting dependents that are dependents of the specific employee that we're looking at. Again, since this is a correlated query, you can think of it as being executed as this nested query here being executed for each tuple in our employee table. Okay, so let's look at something slightly different. Well, it's actually still quite related. So here we're going to look at another example for nested queries and aggregate functions. So let's say we want to define the total salary expense of a department as the sum of the salaries of all employees in that department, right? So everyone, for instance, who works in the research department, we just want to sum up all the salaries, and we want to do that for each department. Okay, so So actually, let me come back to this example later after we discussed the group by clause. Let me jump ahead. So let's look at group by clauses. So group by is followed by an attribute list called the grouping attributes. And what group by does is it partitions the tuples in a table into disjoint subsets, also called groups. So when is it useful? Well, it's useful for applying aggregate functions to each group independently. Okay, so in that example that I just mentioned that I didn't show you yet fully how to solve, where I want to compute the total salary expense for each department, basically we want to apply the sum to each department, right? But we don't want to sum up all the salaries. We just want to sum up the salaries of each group. Okay, and the way these groups are defined when you do a partitioning is that all the tuples will need to have the same value for these grouping attributes, which are the ones that you specify after the group by keywords. So when you use these grouping attributes, then you also need to add them to your select clause. And the reason for that is that you need to associate the aggregate value for a specific group that you're computing with the value of the grouping attribute. So again, let's look at some examples that will make things clearer. So let's say we want to retrieve for each department, the department number, the number of employees in the department, and the average salary. So how are we going to do that? Well, first of all, let's look at the current state of our database. Right, so since I want to retrieve for each department the department number, the number of employees in the department, and the average salary, I need to group the tuples here according to the department number, right? So this is a subset of the state in our current employee table, and I want to group the tuples in here into groups where each group needs to have the same department number. So this will be one group, and these three tuples here will be in one group, and this single tuple here will form its own group. All right, and then over here, this is the result that I would like to get, right? So for each department, so I have three different departments here, 5, 4, and 1. I want the number of employees in that department and also the average salary. So now the final step here is to actually show you the query. Okay, so what is going on here? Well, we're selecting from the employee table, and I'm selecting, and what we're doing here is we're grouping this table by the department number attribute. Okay, so this is my grouping attribute, this DNO. So this statement here, group by DNO, is going to create this partition, right? So it's going to create disjoint subsets, 3 in this case. And now I'm going to apply these aggregate functions, count and average salary, not to the whole table anymore, but to each one of these subsets. Okay, and this is the result that we get, right? So count asterisk applied to the first subset will just count 4 tuples. The second one will count 3, and to the third one 1. And similarly, when we apply this average function to the salary attribute of the first group, this is what we get as a result. This is for the second group, and this is for the third group. Okay. So you're not really creating a new table. There's a question in the chat about that, right? So what I'm doing is I'm just grouping the tuples of this table. Okay, so just think of these here as being your a partition of your current table. And then I'm just operating on the sets of that partition, in the sense of applying these aggregate functions to each one of the sets or groups. Yeah, you can think of the original table as temporarily being changed into a group table. That's it. So again, if null values exist, we need to be careful. Some of the grouping values, attributes that we specify here might have null values because they're not necessarily keys. In that case, what we end up with is, again, a partitioning. So we'll have some partitions, all the sets for the possible where the tuples are grouped according to their values, but we also have one extra group for all the tuples that have a null value. All right. You can also apply group by if you join two or more relations, right? So in this case, we only have a single relation, but we'll see some examples where we have multiple. And you can use it in conjunction with the where clause, which will be performed before the group by clause. Meaning I'm first going to filter out all the tuples that don't satisfy the conditions specified in the where clause, and then I will just do this grouping, meaning this partitioning, into subsets on the rest. Again, let's look at another example here. So for each project, let's retrieve the project number, the project name, and the number of employees who work on that project. And why don't we try to write the answer in the chat for a change? If you know the answer, feel free to write it there. Meanwhile, I can answer some questions. So one question is whether it means that if null is present, then it forms another table. So not another table, but a separate group. Okay. Yeah, it's not a separate row, but like a separate. So a group is like a set of these rows, a subset of these rows. All right. And I guess nobody feels like solving this query now, so let me give you the answer. Okay, so as we said here, we want to select for each project. So we're going to select from project, the project number, project name, and the number of employees who work on that project. Okay, so since we're looking at the number of employees working on a project, we need to also select not just from the project table, but also from the works on table. So we're going to join these two tables, works on a project, using this join condition here, p number equals TNO. All right, so now we have this join table. And then we're going to group by these two attributes. Okay, so p number and p name. All right. Meaning that, so what does this mean, group by p number and p name? Well, it just means that all tuples that have the same value for both of these will be in the same group. And I will form as many groups as needed, such that each tuple is in one of them. All right. And then I'm just returning for each group the project number and project name, right? Because all the tuples in that group have the same project number and project name, and the number of tuples in that group. There's a question, first the p number, then p name. No, so both of these need to be the same, right? So only tuples that have the same value in both of these will end up in the same group. Yeah, so if you remember in the company database, p name, well, I think pname was actually pname was not a key. So pname is not necessarily unique, right? But so you can have tuples in the group, let's say project number 1, and what was it, project XYZ. But maybe you have another project with the same name. But of course, a different project number. Okay, so in that case, you'll have 2 groups. So all the tuples that satisfy this, and all the tuples that satisfy this. All right, so when we use the group by clause, we can also use this having clause that provides a condition to select or reject an entire group. So what do I mean by that? Well, if you think back how the where condition works, it filters out tuples, right? So it checks whether some attributes satisfy some values, for instance, and if not, then it just discards the tuple. So similarly, what the having clause does is it checks whether the group satisfies a condition, and if not, it's just going to discard the entire group. Okay, so you have to use the having clause in conjunction with a group by clause. You can't use them separately. And again, it becomes clearer once we look at an example. So let's say for each project on which more than 2 employees work, we want to retrieve the project number, the project name, and the number of employees who work on the project. All right, so let's look at the query for that. So we're selecting from project and works on. And the condition is, again, this join condition here, right? So we're joining these 2. And we're grouping by the project number and project name. And now, so far, the statements up to here have created this partitioning, right? So we have already created this partitioning of our tuples into these subsets where all the tuples in the same subset have the same P number and the same P name. And now I'm adding this, and I'm looking at this condition here, this condition in the having clause. So now I'm going to check for each group, for each subset that I have, whether this condition holds, whether there are at least 2 tuples. That's what the count function does, right? It counts the number of tuples in a group. Sorry, not at least 2 tuples, but more than 2 tuples. If there are more than 2 tuples in a group, then I'm including it in the result set. Otherwise, I'm going to discard it. So the important point here is that we first perform this condition in the where clause, right? So we first do this join, and only then we're doing the grouping, right? So we're grouping by P number and P name, and only then we're performing the condition in the having clause. Okay, so let's look at what this would do to our state in the database. And sorry that this is rather small, but otherwise I can't fit it onto the slides. So here on the left-hand side, we're looking at the result that we get after we join the project and the works on table, right? So we get this join table here. And now here on the right-hand side, you can already see that we have this grouping of the tuples into groups that have the same P name and P number. So for instance, these 2 and these 3 here, and these 2, and so on. All right, and then I'm performing the having, the check in the having clause here, right? So I'm checking, are there more than 2 tuples in the first group? No, so I'm going to discard the entire first group. There are more than 2 tuples in the second group, so I will include it. Similarly, for this group, I'm going to discard it, and so on. So there's a question, can we do this with where peanut? So you mean just the count here? No, you can't just you can't just like forget about this and add it like this, right? Because there's no grouping going on here, right? And also, and even if you let's say we do want to include this group here, this grouping statement, let's say we're just thinking about removing this having clause, still it's not the same, right? Because as I mentioned, the where clause will be evaluated before this grouping takes place. So we haven't grouped yet. Okay, so this count asterisk here doesn't really make sense. Okay. All right. Yeah, so here it says again what I just mentioned, right? The where clause is executed first to select individual tuples from the joined table, and then later on we apply the having clause to select the individual groups. Okay, so let's look at one more example here. We want to count the total number of employees whose salaries exceed 40,000 in each department, but only for departments where more than 5 employees work. Okay, so how about this SQL statement? Is that going to give us what we want? What do you think? And I guess those of you who already downloaded the slides know the answer, but maybe you haven't looked at it yet. So what is it going to do? Well, actually, it's incorrect, this query. So it will just select the department numbers, right, that have more than 5 employees. This is from the having clause. But each one of these employees needs to have a salary that is greater than 40,000. Okay, so this is not what we want here. Let's look at this instead. Okay, and now you can see that we have a nested query. All right, so for a specific employee, we are going to do this, this nested query here. So we're going to select the department number from employee, and we're grouping by the department number with the condition that the resulting group has at least 5, has more than 5 couples. Okay, so so this condition here, this DNO here, so this ensures that the DNO number is inside the result set, right? So this ensures that we're only looking at employees that work in departments where more than 5 employees work. All right. And here, again, we need this salary greater than 40,000 condition. And since what we want to count, rather return, is the total number of employees whose salaries exceed that, right? So that's why we still need to now do this group by the department number. And up here, we're computing the actual, the actual number of employees whose salary is above that. Okay, so the difference is that here we are selecting from the employee table before we perform this filtering out of employees that earn more than 40,000. All right. And yeah, I didn't get a chance to fully tell you about this one example here, but maybe as a last thing for today, we can do that. Was it? Let me see. Now we find it. Here we are. Right, so let me just quickly finish this. So we defined the total salary expense of the department as the sum of the salaries of all employees in that department. And now let's say we want to compute the average of all departments of the total salary expense. So how do we do that? Well, we can use a nested query, but now the nested query is part of the from clause. So it's not, it doesn't show up when we have the where. Okay. So what is happening here is that in this inner nested query, we're selecting. So first of all, we're grouping the employees according to the department they're working in, according to the department number, and then we're just summing up the salary for each department. Okay, and we're calling the resulting attribute total salary exp, which stands for total salary expense. Okay, and we're returning the department number and this total salary expense. All right, so this, we're kind of creating something that is called the derived table. Okay, so if you have such a such a select statement inside your from clause, you call this a derived table, and I'm even giving it an alias. I'm calling it T. And then up here, I'm just going to compute the average of this total salary expense attributes in this table. All right. Okay. So there's some questions about the midterm. Yeah, there will be some SQL questions for the midterm. So the as, you can add an as if you want, but most SQL implementations don't require you to write the as here, so I omitted it. And in Oracle, you can also omit it if you like. There's a question. So the second part of select will store in C. So think of this select statement here as creating kind of another table, right? So a table that we call T. And then up here, we're selecting from this table T. And here, so you're asking if you can, so I think for attributes, you need to include it, but again, some implementations don't require you to include it. So for attributes, I would include it just because it makes it clearer, and it might be even required. So again, there's a question, is advanced SQL. So you will need to write some SQL queries, but not for these group by and having clauses. Okay, so I understand that those are a bit more difficult. All right. But yeah, I mean, nested queries in general are not, they might show up, but again, as I mentioned, so not with these group by and having clauses. What is the difference between T and total salary expense in terms of attributes elements? So total salary expense is just an attribute of this table T here. Okay. And there's another question about assignment 1. So let me follow up with how the TAs, how they're doing with the grading. They will finish soon. All right, so if there are no other questions, then that concludes today's lecture. And I'll see some of you in the tutorial and the rest of you in rather the midterm, not the lecture. So yeah, I'll send out another email about duration and all that stuff, how you can access it. I'll send an announcement after the class. You should get it from Canvas. Thanks.